Hello, good afternoon, everyone. And I hope that you all are doing good, happy, sound, and healthy at wherever you're taking this session from. And I would like to extend my hearty welcome everyone who will be joining now and who will be joining later in the event. So today we have joined for a special event slash webinar on from data to decisions, unveiling the role of data scientists in industry. And I hope that you're also as eager as I am to know what actually data scientists do in the industry and how actually they excel in the industry. So for this, we have our expert here. So I shall introduce you to our expert. We have Mr. Urvinder Singh. He is a data scientist in Colgate Palmolive, and he has over 6+ years of experience in creating compelling proposals with technologies like machine learning, predictive modeling, data analytics, visualization, time series analysis, statistical modeling, and natural language processing as well. And he has provided more than 1,000+ hours of DS to audience in India and the US as well. So, sir, it is a pleasure for us to be here, to be able to listen you in the webinar. And sir, I would just like to request you to kindly take over the screen, and over to you, sir.
Yeah, sure. Thank you. Thank you. So before I share my screen, so thank you for setting up such a good context. I won't be able to introduce much so anyways, you have done a lot. So thank you everyone for whosoever has joined online. So myself, Urvinda, as Himanshi has already told you. So as today's session is more about from data to decision, we need to understand why there is a boom of data everywhere. Like currently everyone is being talking about data. Every organization is coming into the picture, coming and setting up the vertical for data analytics. Now this particular word or this particular terminology came into the existence, like this took a boom in last 7 or rather you can say 10-12 years. Before that, these people were working in disguise, but still this world or rather this particular world was still present. Now if we talk about data and decisions, I want to share something with you all guys, and then I wanted to show you like why we say that analytics is so important. So if I show you this particular data and just tell me, like looking at this data, if I ask you like what from this particular data you can drive for me, what all information you can drive for me for this particular just by looking at the data. So the moment you look at the numbers, you will be like, okay, let's do some arithmetic or you can say operations, let's do some aggregations, XYZ, something like this. But the moment you start working on those aggregations, looking at this data, you'll be like, what am I getting the result of? The level of aggregation that I'm trying to play here, is it making any sense to me? If I will be calculating the mean of this particular thing or average of something particular or rather of any particular data, will that particular aggregation make any sense to me? Or if it is making sense to me, what actually I can build a story on top of it? So I'll show you the power of analytics, or rather the first vertical in data science field, that is data visualization. That is the first and the foremost pillar in the field of data science, or we also call it any, like you can say data visualization, you can say data presentations, etc., etc. There are a lot many terms when it comes to data visualization, but I'll show you the power of what data visualization actually holds. And many people actually undermine the performance or rather the actual power of data visualization. So what I'll do, I'll bring this particular data into a visualization form, and then from there I'll show you, or rather I'll set up a base like why this is important, because this is the type of data that you will be having, and what is the story and what is the result that you will be expected being a person from analytics field is something that I'm going to show you now. So this is the tool that I'll be using, and this is an Tableau or rather business intelligence tool. So I've connected this particular data, and if you see here, these are the 3 column that we were seeing here. Now what I'll do not much, but if you can see my screen, I'm just doing nothing, but I'm just going to plot this particular data points, that is the 3 vertical columns that I had. Now, if you see this, still, you will not be able to understand basically what is all this data all about. But the moment I'll change the aspect ratio of it. Now, the moment you will see this particular image, you will able to understand what this particular data is. Now, if you see this data and if you see this particular data, you will be like, okay, this data is something about the scan. Now, me being an analytics guy or you being an analytics guy, what actually is asked or rather what is basically expected from you is how simplified the empirical formula or the empirical result you can transform to. How easily the person who is not coming from a core technical background can understand what actually you're trying to present. Now, looking at this thing, we can easily see that this particular thing is actually a scan or rather an MRI scan of your brain. And if we see these two areas, these are basically your eyes. Now, if I ask you like, what is being an anomalous part here? You might be a bit, you can say, skeptical as to what is going wrong here. Like you need to have a bit of empirical knowledge here. Now, what if I apply an unsupervised learning technique that is a part of deep learning vertical? Now, the moment I'll apply this, now you can see this. This is a colored form of your MRI scan. And from here, we can see that this eye is not exactly what this eye is looking like. So it basically means that there is some issue with your eye. So from here, you can see that what we started with and where we ended it. So this is a very simplified and a personified form of what a data to decision makes. You got a data and now you're able to make a decision that something is wrong with the eye. Now we need to do something about it. So this is a very, very simple and a generic example that you can take into your real world form, or you can use it as a hyperbole or something. That we started with a very raw form of the data, and here we are in the state that we can take decision in a very visual form. Now, starting with a presentation form, just let me know, Himani, like my presentation is visible or not.
It is, sir. It is.
Okay. So that was just one particular agenda. Now coming to the other part, like what is the agenda of our today's session that we have here? So we know that what is data science. So we need to know like what, why, and why now. It was there earlier also, but now why we need this particular data science in the current form. Then what are the different type of modeling approaches we do? And then the most important part of the session is what are the strategic use cases. Okay, sorry, I think there is a typo error. Basically, what are the different use cases that we use in different industrial domains? And one very common question, what are the different roles and salaries we can expect? And then I'll be keeping the forum open for the last 15 minutes so that we can interact much. And if you have any questions, and we can interact accordingly. So what data science you understand? When the term comes as a data science, what do you basically mean by the term data science? Now, whenever something, so in the name itself, it is very much clear, data and science. The science that we deals with data, incorporating a lot of, you can say, mathematical approaches, computer languages, etc., etc., is called as data science, a field where you can incorporate data and generate results that can be very much easily or rather interpretable to a normal naive person who is not at all a part of that particular industry, domain, etc. Now, why and how we interpret machine learning. Now, the first, you can see the first diagram, if you see, that is a classical learning that we look for. So what we do, we have a set of data, we have a set of rules, and then we apply a classical learning to get our answer. So if I give you an example of how this classical learning looks like. So if I say that, if I say 2 raised to the power 2, it actually means 2 times, basically means 2 into 2. So what is the rule? The data is 2 raised to power 2, and the rule is 2 cross 2, means 2 times 2. That is the rule. And the classical learning will understand, okay, if this is the type and the rule is this, what I have to do is 2 times 2 I have to do, and the answer will be 4. So this is a very generic classical learning. And if I say that, if I'm giving you a glass, how you have to pour water into it, it is a very simple classical learning of it. Now coming to the machine learning. Machine learning is much more advanced version of it, where we tell and create a, you can say, a replica of what we think as. It is something like you're training a human being. a learning, or rather making a machine learn and replicate the way a human, or rather the human brain works. So what I'll be telling is, I'll be telling the machine that, okay, this is the data and these are the answers. Now you are the one who have to create the linkages. You have to the one who need to understand the patterns. You are the one who needs to understand the rules. Like what are the rules that goes into it so that I can get this result. So it makes, you can say, we are making the machine go through some of the various adversaries so that it can understand in a much, you can say, typical way and much more granular way. And so that it can understand the problem in a more generalized form. Generalized form basically means it should not be restricted to these set of data only. If I give some other set of data, it can interpret the results based on the rules that it has understood. So that is the type of machine learning that we are capable of, or rather we need ourselves to be capable of building. So this is something that we push the data. We ask the machine to understand that what should be the, you can say, correlations, what are should be the patterns, so that we can get this set of answer. So it will understand what are the patterns between your input and your output from the training part, and then it will start learning accordingly. Now, if I give you a very simple example on this thing is, we try to make, or rather we tend to make decisions in our life, and how these decisions are tend to be driven. These are based on the learning that you have done in your past. These are based on your, you can say, experiences, cognitive learnings. So this is something that is replica of machine learning, or rather machine learning is the replica of what we are learning, or how we have learned over the time. So we have learned that if I'll be doing this, I'll be getting an answer something like this, and if not, then this. So I have understood all the rules. Like if I'll be doing this, I know what type of rule will be implied so that this is the result that I might be getting. So this is what we basically do, and this comes under the term that is called an artificial engineering, sorry, or we can also say artificial intelligence. Now if you look at this particular diagram, how we move over time and time. We start with artificial intelligence. So what comes under artificial intelligence is something like your robotics, your statistical modeling, your rule-based learning, anything which can represent the intelligence of a human brain. Then comes machine learning. Now, what comes into machine learning is when you want more complex data and you want the machine or the model to learn from the data and start reproducing the results. That is more into a complex form. And further, we have something that is called as deep learning. Deep learning is when you are unable to handle a data that is into a structural form or structured data. That is something like, moving forward, I'll be telling you that also, like what all different datas we have in. Like we'll be having something in unstructured form like audio, video, text. These are the three unstructured data that we work with. And then the combination of everything is called as data science. Combination of this part along with your mathematical part, your statistical part, your EDA, visualization, XYZ things, you come together and can create a holistic, you can say, domain that is called as data science. So data science standalone is nothing but it is a club of multiple learnings and domains and industries that works in one single form that is called data science. Now, this is a simple architecture. Like you can do multiple kind of stuff. Like you can do classification, you can do clustering, dimensionality reduction, regression, etc., based on the type of data that you have. Like if I want to predict a value, what you want to do, if you want to do with classification means the category thing, then you will be going with something on the classification end. If you are not aware what I have to do, then what you do, you start understanding the patterns of the data, and then you start making sense of it. So this is overall the technical aspect of it. Now, why data science? This is the most important thing because we have just seen the boom of analytics in the field of business domains. The reason is they have started understanding what value we as data analytics people bring it on the table. Now, if I give you, or rather, if I tell you that you have to go from position A to position B, you can take any sort of the path on the map, or rather, if I have not given you the map, I've just told you that you have to go from place A to place B. Now you have multiple options to take with. But if I give you a approach which is more data driven, that will tell you that which path will give you the less amount of time, which path will help you to cater less distance, and which path is the smoothest road or the path you will be getting. So that will help you in reducing your operational costs like your fuel, etc., your time. It will try to reduce and optimize that part. So this is what basically we need. We need data-driven decision making instead of intuition-based decision making. Now, the best example, if I try to quote here, is like if I ask you, like in India on FMCG products, okay, in India in FMCG products, if people spend 100 rupees, what is the percentage that e-commerce people, or rather what will be the percentage the people will be spending on e-commerce platform? So you might be coming across the numbers like 20, 30, because this is based on my past experience, because I quote this example. Now you will not be having the actual data, therefore you will be going with some intuitions. Okay, let's do this thing, let's do this thing. It is all about the intuition. Okay, so what you will try to do is, if my consumption is around on 50%, you will try to say, okay, 50 to 40% or 40 to 50%, 50 to 60%. You'll try to give some a lump sum number on top of it. But when you actually see the data, the number is very different. It is around only 4.76% in India. The e-commerce platform generate the sales. Major sale, that is 80% of the sale, is actually driven by a normal kirana or wholesale or general stores. This is where the data decision making comes into the picture. You have the data, you try building a lot of, you can say, churning part of it. You churn a lot of data, you try digging into it, and you get to know, okay, what is this all about? And this is the reason which has helped us, we analytics professional, to gain and, you can say, market our domain into a very fancy domain. And second is enabling valuable insights. Now, when you know based on your past data that when you have done this part, what was the result that you have got, whether the result was good or bad. If my model, if I have a simulation which can help me understand the patterns in my data based on my past behavior, and if I have to replicate something in the future, that particular model or my simulation will tell me that if you will be repeating something the same, either you will be getting something as a profit, or if you will be repeating something in this form, you might be getting a loss. So basically what is happening over here is that data is helping me to take important steps. Data is making me enabled to take better steps based on the insights that it has generated from the past data. And second, or rather, it is not the last one. These are some of the major bullet points, but there can be n number of bullet points into this part. Second is unlocking the right potential. Now, if I tell you that you can understand, suppose you are part of any product company and you are running a multiple type of schemes. Now, if from the data I can tell you that on which platform you should be running more part of the scheme, more, you should invest more of your part of your campaign, whether on social media or your print media. So this will help you to strategize your complete investment. This will help you to make your decision in a more strategic manner. And why? And why basically we need data science? This is the power of data science that I'll be talking in the next slide. That is why data science now. Now, first is, sorry. Mm. Now, before moving to the part that why data science now, just look at this particular table. This table, or rather this graph, is nothing but this is what Moore's law states. Moore's laws basically state with every 2 year, change in every 2 year, you will see an exponential growth or double the use of transistors, or you can say chips. Now, if I give an example how the chips industry is changing, when you were in early 2000, no one would have ever imagined that you will be getting a smart television, smart fridge, smart car. And now currently we are staying in the, or rather living in a world where everything is smart. And what is making everything smart? What is enabling the word smart in every electrical or electronic appliances? These are your semiconductors, or you can say the chips. And with every chip, you generate more and more data. The more and more the data you have, the more and more the potential you have to generate more and more insights and take more and more better decision making power, or rather it gives you the leverage to take better decisions. Now, why data science and why now? The reason is explosion of data, which I've showed you in the last slide, that we have n number of chips and we have n number of data that we have. Now, if you have read the book of one of Eric Schmidt, one of the CEO of Google, he said that the data that was generated in the world till 2003, let's say the total data is X, the same amount of data in current world is generated every 2 days. And in 2023, that same amount of data is generated every day. Now you can imagine the type of data or the amount of data that we have. Now, if we are generating so much amount of data, we can use it in a best possible form. Many conglomerates are saying that data is the new oil. Why they are saying data is the new oil? Because they know the potential of it. And why data science? Every business unit is building up the unit of data science, because they know the potential that data science can help us to generate better ROIs. ROIs is return on investment, where I can optimize my spend, or you can say reduce my spends, but I can increase my output or increase my gains. So it helps me to understand which is the right factor to invest, which is the right factor to play with. And second is every you can say component, every component of the domain of different industries are working into AI and ML. Every industry has unleashed the potential of it. And second is unethical and privacy concerns. So this is not a con. This is basically the advantage why we are using AI ML. AI ML helps you to do this all this cybersecurity stuff. You use a lot of AI ML algorithms. There are a lot of apps present which can help you to understand whether your passwords are, you can say, exposed to dark web or not. So that is the power of your deep learning, or rather that is the power of your analytics. And therefore the business has able to understand that if I want to optimize my inputs, that is optimize my spends and generate higher outputs or generate higher gains, higher ROIs, only data is something that can help me, because data can easily read through what is going on in your past. And if you keep on taking the same set of decisions, you might either end up falling into a pit, or you might be flourishing it. So data will play a very, you can say, validation point. Now, from where we start and where we land, first of all, we need to understand we have a set of raw data and how we start making decisions. So there are four, you can say, steps or ladder points in which you start making decisions from the data. And I'll give you a very simple example how you can understand this thing. So this is basically different modeling aspects. So there are four types of majorly modeling aspects. One is descriptive, diagnostic, then you have predictive, and then you have prescriptive. Now, when it comes to descriptive, so I'll explain you with a very simple example of you visiting a doctor's clinic. So the moment you visit the doctor's clinic, what do? You first of all describe to the doctor what has happened to you, why you're having something like this, or what you are actually having, what has happened to you. Then based on what has happened, what you do, or rather what the doctor does is, it will try to understand why did it happen, why the thing that you're trying to describe is happening. It will try to diagnose that particular thing. Now then what the doctor will do, it will try to predict that if I give this particular tablet of prescription, based on this prescription, this particular scenario that you are explaining to me, might I'm able to control it or eliminate it. And then it will decide, or rather then particular doctor will give you the best set of, or rather it will able to predict, and then it will give you the last step, that is prescription, that if I don't give any medicine, what will happen in the future. And if I give you this particular prescription, that is if I give you this particular medicine, what might happen, what will happen. It will be able to control the particular area, or rather control the, you can say, the disease or something that is happening to you, or it might able to eliminate it. So this is the same journey that we use it in our machine learning aspect. We get the data, we try understanding, we do a lot of EDA. There is a term that is called EDA. EDA is exploratory data analysis. And what basically we do in EDA is we start scratching a lot of data. We make multiple graphs. We make multiple, you can say, visualization. We do a lot of statistical stuff as to what is going inside the data. What is a type of trend, whether my sales is going up, whether my sales are going down, when, after which period my sales started going down, or after which period my sales took a lift. So this is a part of your descriptive and diagnostic, and majority of the business questions you will be able to answer during these two steps. And I can say from my past experience, almost 7 years of experience, I can easily say that you can get almost 70 to 75% of the questions what business is tending to ask in these two steps, these two types of modeling approach. And then is using the same data, how I can use the same data to predict my future, to forecast my future. What will my future look like? Something we say in the normal sales say is sales forecasting or demand forecasting. Looking at the past trend, can I predict something? What will be my future trend, future demand of my particular product, so that I can properly align my inventory? That is called prescription. So this is the model will tell you that your sales are going to go top of the roof. Now, what you have to do, you as a person into the inventory management, you will align the inventory accordingly so that you have ample amount of space to bring that production in line and store it and deliver it and logistic. You will do all kind of CSNL part, that is supply chain stuff, correct? So this is what the different modeling approaches look like. You need not to apply all the one in just one go. And there is always a ladder. There is always a sequence to it. You have the data, then you describe it. Describe basically means you study the data. What is going inside the data? You start understanding the data. You then start taking this, going into the diagnostic part, and then you start making decisions. So there is a sequence. You cannot move from step two to, you cannot start with step three directly. There is a sequence. You always start with step one. Therefore, the journey of data to decision starts. You from the data itself, you will be able to understand, okay, whether you're doing good or not. You do a lot of combinational correlation stuff, and then you come to the particular stance that what your hypothesis is. So hypothesis is something, is the very first thing that you start with. That is, until and unless you have hypothesis in your mind, there is no point of making any kind of a model. Because hypothesis is basically means that whatever you are thinking, your model might do it better, or whatever you are thinking is wrong, and I will prove it that you are going, whatever you're thinking is wrong. So that is the reason, until and unless you have an hypothesis that is null or alternate, these are various, there are different type of tests to check your hypothesis. Until and unless you have an hypothesis, there is no point making advances in your analytics journey or other analytics journey of your project. So you have to set up your first, you have to set up your hypotheses, and then you start making it, and or rather start conquering your use cases or whatever you want to do it on top of it. And what are the different type of use cases and examples, and how this data is helping us, and how what actually the industries are trying to do. So what I have done here is I've tried collating multiple use cases from different industry that I worked with or other have some exposure to, so that you can easily relate moving forward if you want to get an exposure into this kind of a domain, what all things you might work with. And I'll be explaining you some of the use cases as to what are being what are these use cases are actually about. Now, the first is FMCG. So FMCG is fast moving consumer products like biscuits, toothpaste, then your normal eatables, something like stuff. So these are basically part of your FMCG. Now, FMCG is a very, very, you can say, a vast field where you can do a lot of stuff. First is you can do personalized recommendation. Personalized recommendation is something you can enable a salesman that instead of selling the products that comes to your mind and ask the shopkeeper, okay, these are the product, do you want to buy it from our company or not? Instead of that, what if I can generate a recommendation engine for that particular store, and that recommendation help me that what is the right potential of this particular store, and what are the right product that I can ask this particular person to sell to this particular shopper. This is called as personalized recommendation. And now currently in the field of social media, everything is personalized. You will find personalized ads, you will find personalized recommendation on YouTube videos, you will get personalized videos on Facebook, be it anything. You will find personalized news on your Google News, etc., etc. Everything in personalized because it is based on your behavior. It is based on your past you can say interaction with the data. Then is media effectiveness. This media effective, what basically means, there is a word that we call in FMCG that is called market mix modeling or media mix modeling. Now, what do we basically do in media mix effectiveness or media mix modeling is we try to understand if I'm spending, let's say, $100 in multiple media platforms like TV, newspaper, social media apps like YouTube, Instagram, Facebook. I'm running a campaign of a particular product. From which particular campaign, or rather, from which particular platform I'm generating better ROI? And what is the return number? What is the return in my effectiveness? And using those terms, I can easily optimize my spend. So instead of allocating exact same numbers, that is $10 or $15, now I know that if I'll be investing $10 in this particular platform, I'll be getting a return of $100. And this is how this particular use case help you to optimize the complete spends. Then is price and promotional optimization. Price and promotion is basically a BTL kind of an approach. That is, you get a lot of promotional data. Like every company runs a lot of promotion schemes. You might be getting 5% discount. You might be getting 10% discount. And how to analyze this, whether this particular scheme is working well or not? What is the elasticity? There's economic terms involved here. Is what is the elasticity of the product? Means if I'm reducing my promotion, what is the dip in the sale that I can expect? If I'm increasing my promotion, what is the sales dip, or you can say increase I can expect? Same way with the price. So these are the things. You get a raw data, you get some sales data, you get some promotional data, and then you start applying a lot of regressional modeling stuff. And from there, you start developing a model that, okay, if I'll be increasing my price by 1%, I can see the sales of this particular product might go 50% down or 10% up. And using these modeling stuff, you take a very, very healthy decision. And this will help the model, sorry, this will help the business, or rather the business model, to optimize their spend so that they just don't go with their intuition stuff or their normal classical method. They should be going with a much more robust method to it. Then is route optimization, demand forecasting, inventory planning. Route optimization basically means if I logistic, like if a van is going from warehouse to the, you can say, store, which is the right route to follow so that it can reduce its operational costs like fuel, time, distance. Second, when it comes to oil and gas field, first is plant safety, predictive maintenance. Like if I can use something like I can push or you can say a model into the camera itself that will detect, okay, whether the person is wearing safety jacket or not, whether the person is wearing helmet or not. And that particular camera will record that particular data and send a notification to that particular guy. And this particular model is basically used in a lot of plants that I've worked with. So what we do is we get a lot of data and then we then generate a lot of, like, we apply a lot of computer vision kind of stuff, and then we do these kind of stuff. Predictive maintenance. Predictive maintenance means when you are doing working with a very heavy machinery kind of a stuff, you cannot wait for the machine to stop because of some breakdown. You have to do a regular maintenance of it. And predictive maintenance will help us to understand when is the next possible failure that can happen so that I can do the maintenance on time. This is what can happen over the time. Energy trading and pricing. How I can change the pricing of my energy means oil. What is the, how I can change the, you can say, pricing of my gas based on the customer. Because if I want to sell oil to, or rather, let's say liquid oxygen, if I want to sell something into the chemicals to the various different customers, I cannot sell everyone with the same price. I need to understand what is the ROI that I'll be generating. So every person will be having a different and dynamic pricing of it. Upstream process, midstream process, downstream process. Upstream is how we can drill it. How you can use multiple IoT sensors to tell whether this is the right place to drill for your oil field or not, oil well or not. Then midstream, how you can store it. Downstream, how you can do the logistic part, transportation part. Telecommunication comes to the capacity planning, how many towers you need, how many, you can say, when it comes to network security, what are the type of, uh, you can say, what are the type of parameters you should be using? What is the customer life cycle value when it comes to the operator and XYZ? Then comes Your BFSI. BFSI is banking sector or financial sector. It comes like, if I can understand what is the credit scoring, what is the underwriting process. This is the use cases that are done using analytics. If I can understand which is the right using analytics, and this has been done. Axis Bank was the first one to do this ATM network analysis. They were the one who were able to understand, okay, what are the right places to invest in so that we can get the best ROI of our ATMs. That is means that what is the right place to invest in the property where we can install our ATM? What is the right place for it? And how we were able to understand this, or rather how we were able to do this thing. We were able to understand what all data we goes into it. What is the type of people living? What is the level of spend they go? What is whether the spend is more into cash, whether the spend is more digital, whether the spend is more into XYZ other form, and in what commodity people do. What is the area? How many ATMs are already part of that area? How many banks are there in the part of in that area locality? Is there any like based on these all different parameters, we were able to take a decision that whether this particular area needs an ATM or not, and in which exact location, geo place that this particular ATM needs to be done. Risk management, fraud detection, whether there is a fraudulent transaction or not. You might be getting, so suddenly you do a very, suppose your normal scan is around, let's say 5 to 10,000, and suddenly you do a swipe of around 60 to 70,000. You will be getting a message that have you done this transaction, or was it someone else, or rather you were the one who has done this, because it has detected an anomaly in your normal behavior. So it has raised a notification, and this will help us to detect fraud. And last, and the most, you can say, exciting portion of the, you can say, part, that is roles and salary packages. So there is no number. I'll be not quoting the numbers because every industry has a certain set of numbers to it. I'll be explaining the different type of industry that you can cater to. Now, before going to that part, let's understand the different roles which you can serve and perform based on when it comes to analytics field. One is business analyst. So the right person of business analyst is a person who understands both the business and analytics, and he can act as a bridge between the analytics and the business people. He act as a business translator. He can easily communicate between the business and the analytic. He know how the business is doing, or rather how the business works, and he also knows what somewhat about the analytics, so that the analytics guys can easily understand the way the business is thinking. He will, you can say, modulate the version of business into analytics stuff. The data analyst, a data analyst can be a person who is churning the data, cleaning the data, building dashboards, building valuable insight, generating reports, doing automations, building dynamic reportings, XYZ. Then comes data engineering. Data engineering is the most important, you can say, position in the field of, or rather the position or role in the field of analytics. This position or this person is the one who will be able to, or rather who will be the one who will be creating lakes for your data. Lakes basically means repositories for your data. He'll be the one who will be creating pipelines so that he can use your data. He'll be the one who will be creating the repository and bringing all the data at one place. He's the one, the responsible person. Then comes the machine learning engineer. So machine learning engineer, before coming to machine learning engineer, let me tell you. So data visualization engineer and data analyst, there's somewhat an overlap in. So there are some companies who only looks for data visualizations, people who basically mean they are only for building dashboards, whereas data analyst is a person who has to do both data cleaning stuff and everything, visualization along with some automations and stuff. Whereas data visualization is a person who need to just clean and push the data and build visualizations. Now coming to the data scientist. So data scientist is a mix. So as per the analytics field, data scientist should be knowing what is data analytics, or rather he is the mix of business analyst, data analyst, and data visualization, and a bit of data engineer as well. So he will be the one who will be cleaning the data. He'll be the one who will be doing all these stuff. He'll be running all the insights. He'll be building a bit of visualization, understanding the data. He'll be the one building the model. He'll be the one also deploying the model. Or he will be also, sometime what happens, there are some people like in IC role, they are the one who need to create the pipelines also and do the deployment and maintain it also. So a data scientist looks a very simple term, but it has a lot of various roles and responsibility. And now coming to the last part, that is machine learning engineer. So what is machine learning engineer? Machine learning engineer is a mix of data engineer and data scientist. So data science, he knows what basically the modeling stuff is. He knows the modeling part of it, and he also knows what is the data engineering part. And he is the person who maintains the complete operation of your model. And the right term for machine learning engineer is MLOps, machine learning operations. So he's the one who looks at it, he deploy it, maintain it, and keep on checking the model. He checks whether the model is, there is a thrift or not. Do we need to do some tweaks, enhance the model performance or not? So this is basically some of the roles. Now looking at the last part, that is salary. Like, it depends on your role. What role you are looking for? What is the role that you are applying for? And second, what is the portfolio? Suppose you are coming from, you are a fresher. So in analytics, it is expected that you should be doing some projects from your own end. You should be having a bit of hands dirty, so that you build a good, you can say, when people ask something about analytics, you should be available, or rather you should be ready with some kind of an answer to it. So build good amount of project, you go on multiple hackathons, you will be getting multiple hackathons, read about it, practice, try to replicate what people have already done into your own system, and understand why they have done that particular part. And why I have written specifically the project portfolio, because there are some use cases that are very specific and are in demand. Now, if I tell you some of the use cases that are very much in demand in the CPG world, is market mix modeling and price and promotion. If you have these two projects or these two terms, you'll be getting a lot of, like, you can get a good, and you can say handsome CTC in your hand. And it also depends in the type of industry you're working with, whether you are working in a service-based company, or whether you're working with any consultancy, or whether you are into a product company. So these are some of the factors that apply. So therefore, I cannot quote the right number, but looking at the fresher, if you are part of any service industry, you might be getting, and it also depends in India, it also depends on the region, whether it is north or south, it also depends a lot. So I can easily quote around 5 to, you can say 8 is the, you can say, overall range, with a bit of, let's say 80% of the confidence interval when it comes to building up, getting us, you can say, selection into data scientist field. In service, product can be a bit high on towards, you can say, 15 to plus. Consultancy also lies in was very similar phase of what product is. So this is all about what I has to deliver, something a bit on a push end. But any question, the forum is open. Do you have any question? Welcome, or rather happy to answer, guys.
Yeah. Sir, thank you so much. Before we move on to the questionnaire, I'd like to thank you, sir, for coming in, for giving in your time, for presenting this insightful presentation, of course. And sir, we have this question from Navpreet Kaur. So it
Mhm.
says, is data science full of mathematics?
So data science uses the concepts of mathematics. This is not about full mathematics. So if you have an eagerness to learn, so data science is a mix of multiple things. It is not just mathematics. It is also about your linguistics. It is also about your communication skills. It is also about your soft skills, something like communication skills. It is also about your programming languages. It is also about your zeal to learn. So it is not just mathematics. It is a lot of things. So if you know mathematics, if you have a bit of eagerness to learn what mathematics is, you are not expected to write multiple complex, you can say, solve complex equations. If you know how this is working, I think working as a fresher, it is enough to step into it. If you know the know-how, and if you are ready to learn new concept, then it is okay. It is not just mathematics.
Exactly. So I said, basically, if you're from any stream, as in you've chosen maybe let's say commerce or biology for that matter, you can
Hmm.
still come in the data science industry and learn, and hence can excel in the field, right?
Yep, absolutely. There is no hard and fast rule like you have to be coming from this particular thing. The learning curve should always be the key factor. If you have the zeal to learn new stuff, any field you can say, flourish.
Definitely, sir. Sir, we have other question that has came from our registrant. So
Hmm.
it says, how do data scientists actually tell non-data scientist people or non-technical people about I mean, how do they communicate within the, let's say, industries, and
Yeah,
where, you communicate with
yeah,
non-technical person as well.
absolutely. So if I explain you with my personal example, like when we pitch our model or rather that stuff to the business, the approach should be not like from analytics to business. It should be the way you should be thinking for the approach or the use case should be from business to analytics. The moment you start looking from how the business should be looking like, put yourself in the business field or rather the business seat and then think what I can generate to. So when we present any kind of a model to them, we never go into the technical stuff that we have done XYZ modeling stuff, we have done this thing. We tell this is the approach, this is the data that we have, and these are the findings that we got. And looking at the finding, these are the loopholes, these are the one which we can work upon, and these are one who have we have worked upon. And using these things, what we got as a result is this. And with these results, we can see these are the results that we can do. These are the areas we can accomplish. These are the one we have to focus upon. So never go into the technical aspect of it. Therefore, it is always said if you have a bit of business understanding, bit of domain knowledge, it will be always a plus sign. But it will come when you start stepping into it. But keep it very simple. Look how the business is thinking, because business never understand the technical know-hows. Never pitch the technical part. Keep the technical part in your pocket and only come up with the business aspects. What is going on? What is wrong? What can be done? What is the output? And how with this output we can generate better ROIs. If you are using the term ROIs, they will be very much interested into it.
Yeah, definitely, sir. And sir, with this, we have our last question, and it came from Viraha Sharma, and it
Hmm,
says, "How do scientists ensure that they're using the data ethically and maintain the privacy and security in their
got
work?"
it. So this is a very, very open-ended question, but still I'll try to answer this. So you have a very good amount of infrastructure that looks after the security part of it, and that field is altogether comes under the cyber security part. So now machine learning or something like AI is collaborating with your cyber security to develop robust models. Like it will tell you like if there is any leakage of your data or not, if there is any exposure of your data or not. It will go share the trigger point. Is there any anomalous in the RAM? Is there any anomalous part working in your network or not? So it will give you the triggers. So this is how there's a collaboration. But coming to your point of how scientists take care that there is no leakage in the data, it is all about how you're setting up the infrastructure. It is all about the infra. This is how I can answer it.
And sir, with this, I also have this one question in my mind. So, are
Yeah,
there
sure.
any difficulties that are faced by data scientists? Let's say if somebody has become a data scientist or
Hmm.
analyst for that matter. So, what are those responsibilities plus difficulties that professionals face?
See, it is not about, see, difficulties is something like one thing I always tell everyone is like, if you have the power to unlearn to learn something, then there is no difficulty to see in, like any, you will not see any difficulty in learning something new and getting accustomed to something new. And on top of it, always and never go with your fixed mindset that I have learned this and I'll apply this. Because at the end of the day, we as analytics people, we'll be helping the business guys to generate more income or more money in a very simple terms if I try to quote it down. Now, if you are unable to answer what they are thinking and unable to communicate the language which they speak, you will always find it difficult for them to accept what you have done, even though it might create a major, you can say, change or bring, you can say, a revolution to it. So the only difficulty which a newbie will be able to get to accustom or rather will be able to experience is communicating your analytic skills into a very layman term so that the business guy is able to understand it. So this is something which is a bit difficult. And second is we people say as a person coming from analytic field think that they know everything, but that is not the case, because sometimes what happens, people think that you must know about this thing. We expect that the person should be knowing about standard deviation or variance, but this is not the reality. They only understand mean. I'm talking in a very generic form. Therefore, you have to bring and mold your answer in such a way so that you can understand.
Yeah.
You need to explain the same thing, but in a very simple form. That is what we can think of.
Okay, so I think we're done with the questions. So I would like to thank you for giving the resolutions basically of the queries that our participants had. And if any participant have any other query, you can just write in Q&A box or chat box. And meanwhile, I would like to inform everyone, if you have missed any part of this webinar or the session, you can watch it on YouTube as well. And it will be there on our site, that is lpu.in. So explore the site, and there are multiple webinars that are coming in, of course. So you can explore them also and register for them, because they're all free, and gain as much as knowledge you want. So sir, with this, I will take your permission to wrap this webinar up. Can I?
Yeah, please. Thank you. Have a great day.
Yeah,
Take care.
thank you so much, sir. Thank you so much for coming in
Thank
and
you.
providing maybe I would say a path to all the new aspirants who would maybe want to join in the data science industry. And lastly, I would like to thank to all the participants, of course, for coming in and for giving in your questions. So until next webinar, stay safe and stay healthy. And thank you so much for joining in.
Thank you. Thank you.